Hey guys. All right. So today we're talking about probability models, which so exciting because it's so simple. It's a little bit annoying. It's actually really annoying, but it's simple. At least it's not annoying and complicated. So I'm trying to take the wins where I can. So our important vocabulary is going to be sample space and probability. So let's talk about the vocabulary first, right? So sample space is the set of all possible outcomes. So, for example, if you're flipping a coin, it could be land up heads or it could land on tails. So, it's your sample space would be heads, tails. For probability model, you're looking at the sample space. Then you are looking at all events within the sample space and their probabilities. Okay, and we'll explain a little bit more of what that means. But the probability model is the sample space and the probabilities of everything within the sample space. Okay, awesome. So, what does this actually look like? So, I got some snacks here, right? I've got 3 bags of Takis, I've got 2 bags of Flamin' Hot Cheetos, and I got a package of ramen. Awesome. So if I wanted to write the sample space of this, right, I'm basically listing everything that I can choose from. The annoying part of this is that if you have more than one, like see how we have 3 Takis, you're going to have to list the Takis 3 times. Yes, I know, I get it, I hear you, but it's what we got to do, right? So our sample space for this would look like TTT CCR. So we have S equals, that means sample space equals. And there we show that we have 3 Takis to choose from, 2 bags of hot Cheetos to choose from, and 1 ramen. And this is all our choices within our sample space. We can then use that to build our probability model. So probability model is when you say, okay, well, what would be if these were like all in a bag and I just like closed my eyes and reached in, right? What would be the probability that I would pull Takis out? And it's theoretical, right? So it's not experimental, it's theoretical, which is how much of what you're looking for over total amount. So how many Takis are there? 3 out of how many choices total? 6. So my probability model would be 3, 6, or 1/2. If I'm doing this for hot Cheetos, I can look at my sample space, see I have 2 C's. So the probability of C would be 2 out of 6, or 1/3. For ramen, there's only a 1 in 6 chance because there's only one R out of the one ramen out of these 6 different choices, right? There's only one R in our sample space. So that would be why that would be 1/6. Okay. All right. So we're going to get a little bit more into your turn with this. So let's consider the reaping. Okay. Prim had 1 entry. Gail had 42 entries. PETA had 5 entries. Now, I'm not going to make you write out the sample space for this because it would be so annoying, right? Because what can you not do? Yeah, you can't do it the easy way. This is how you would have had to write out the sample space. I was so annoyed while I was doing this. Can I just tell you? And I think I have 42 there. I didn't even go back and count because it was so annoying. So this is, oh, and I guess I should have put like a P1 here, right, for Prim and then a P2 for PETA. So, or a PR and a PE. But anyway, so like looking at our probability model, right? How do you think I could show Prim, the probability of Prim? Take a guess. So Prim had 1 entry. And if I'm looking just at these entries, I can see that there are 48 entries total if I add these up. So Prim's probability out of just those 3 people, would have been 1 out of 48. How about Gail? Take a guess. So yeah, Gail, 42 out of 48, which would simplify to 7/8. And PETA, So for PETA, 5/48. It's really all you're doing with this. Okay, you're using theoretical probability. This is just the annoying part, just writing out the sample space. Okay, so this one, next one, I made a lot nicer and cleaner for you. So Katniss, she's got her backpack, right, with her supplies in it. She reaches in, she grabs the first thing at random, right? The backpack has 2 first aid kits. We're going to use F to represent those. 2 water bottles. We use W to represent those. And a pack of crackers. And we're using C for the crackers. And night vision goggles. We're using N to represent those. What do you think the sample space would look like for this? So hopefully you listed them all out. The sample space for this would be FF, WW, CN, because you have 2 first aid kits, 2 water bottles, 1 thing of crackers, 1 thing of night vision glasses. So now we're going to use that sample space to create like our probability model where we list the probabilities of each thing in the sample space. So let's do that probability model. Okay. So first, let's look at the first aid kits. What would be the probability of her pulling out a first aid kit? What do you think? So for the first aid kit, it would be 2 out of 6, right? Now, where did I get the 2? Because there's 2 first aid kits. Where did I get the 6? There's 6 total options, and that simplifies to 1/3. What about pulling out a water bottle? 2/6 or 1/3. Same as the first aid kit, same probability, because there's 2 of each of them in there. What about a pack of crackers? Yeah, for that, a little bit different, right? There's only 1 C in our sample space, only 1 pack of crackers in that backpack. So that's going to give us 1/6. And night vision glasses? Yeah, it's going to be 1/6 as well. All right. So that is it. That's really it. That's it. If you can, try the challenge, right? Not no worries, but we're going to be doing a lot more with probability model and different ways to represent probability tomorrow and the following day with tree diagrams, organized lists, and tables. So stay tuned. Love you. Bye.